Greetings, math fans. All right, so these are the problems for day 5 homework, and there are 7 of them. So let's get started. The solutions are already in the Google Drive, but as per your request, I am going to do them now, so you can see the video. Okay, so anyway, let's start out here. This is 47. Is cosine of theta plus 1 over tangent squared of theta is equal to cosine of theta over secant of theta minus 1. Now you're going to work on the right hand side because remember it's easier to simplify x plus y over z than it is to simplify z over x plus y. Okay, so you always want to do the more difficult side, which is this side here. Because this one, the left side I can bring up to x over z plus y over z, and the right side I can't do that. So that's why you want to work on that side. Guys, you have one term here, and you got to multiply by its conjugate. Okay, so it's secant of theta plus 1 over secant of theta plus 1. So I'm going to distribute that cosine of theta, secant of theta, plus cosine theta, right? Distribute that. And then the bottom, that's a difference of 2 squares, so you get secant squared of theta minus 1, which is actually really nice because, of course, tangent squared of theta, you don't need to write this out there, but I'm just writing it out for you. Tangent squared of theta plus 1 equals secant squared of theta. So secant squared of theta minus 1 is tangent squared of theta. So I can change that to tangent squared of theta. So let's do that. Tangent squared of theta. And then on top, cosine theta times 1 over cosine theta plus cosine of theta. Okay, and so that, of course, that cancels, and you wind up getting, I'm just going to write it in the correct way here, cosine of theta plus 1 over tangent squared of theta. Now, some of you guys might say, well, gee, now what do I do to simplify this? Well, again, please recognize that we're already there. Okay, you've actually simplified it to the other side, so we're done with the problem. Okay, you don't need to do any more simplifying. Okay? All right, that was reasonable. 49. Okay, now this is going to be a little different. 1 over 1 minus sine of theta plus 1 over 1 plus sine of theta equals 2 secant squared of theta. Of course, the left side is more difficult, and we're going to get a common denominator here. So it's going to be 1 plus sine theta over 1 plus sine of theta. And again, this is all the work I want to see. And this is 1 minus sine of theta. Okay, so at the top, I get 1 plus sine of theta. Now, there's no distributing the positive, obviously, but if that was negative, make sure you distribute it. But anyway, this is plus 1 minus sine of theta. And the bottom is going to be 1 plus sine of theta times 1 minus sine of theta, which is 1 minus sine squared of theta. Once again, nice little friendly identity. You guys should recognize that bottom is cosine squared of theta. And on top, the signs actually cancel, and we have 2, which actually is really nice because that just comes to the top. So it's 2 secant squared of theta equals 2 secant squared of theta. And you get check mark. I don't think I did that with 47 with the check mark, so don't forget the check mark. That's kind of important. Okay? That proves you finished your identity. All right. So next one is 52. All right. So it's 1 minus cosine of x over 1 plus cosine of x equals parentheses cotangent of x minus cosecant of x quantity squared. Well, this was a little more difficult, math fans, to kind of figure out which side's more difficult. Because you might look at the right and say, gee, that's squared. And then you look at the left and say, well, it's a fraction. I would probably say that the left side is more difficult to turn it into. You could probably do it either way, but I'm going to work on the left side, okay? Because I'm just going to do that. All right, so let's do that. 1 minus cosine of x over 1 plus cosine of x. I'm just going to write it out here again. Okay, I'm going to multiply it by the conjugate. So 1 minus cosine of x over 1 minus cosine of x. And on top, you get 1 minus 2 cosine of x plus cosine of x, cosine squared of x. On the bottom, I get sine squared, let me show me my work. 1 minus cosine squared of x. This is what I really want to see, okay? So then the bottom gives me sine squared of x, and the top is 1 minus 2 cosine of x plus cosine squared of x. So what I'm going to do, math fans, is I kind of look at this problem and I see a quantity squared like this. So I kind of see it as, if I look at this side, it's kind of like an ax squared plus bx plus c that factors to a perfect square trinomial. Okay? So what that kind of leads me to believe is I'm going to actually distribute this, that sine squared of x. So I'm going to get 1 over sine squared of x minus 2 cosine of x over sine squared of x plus cosine squared of x over sine squared of x. Okay, so what that's going to give me is 1 over sine squared of x is cosecant squared of x. This, I'm going to write, actually show a little work here. 2 over cosine of x, and then you have sine of x, and that's cotangent squared of x. So that's kind of nice. If you look, math fans, cosecant squared of x is right here. So there's cosecant. And then I have cotangent squared of x, and there's cotangent. So, and then here's my middle term. Now I need to simplify that little middle term. So let me write this out again. And I'm going to rearrange it because I'm going to put the cotangent squared first. So cotangent squared of x. And if I simplify this, it's, look at this right here. 2 cosine of x over sine of x is minus 2 cotangent of x, right? And then 1 over sine of x, that's the second part here, is cosecant of x. Okay? And then plus, again, I'm going to take this cosecant plus cosecant squared of x. Now, I just need to factor that. And if I factor that, you end up getting cotangent of x minus cosecant of x and cotangent of x minus cosecant of x, right? Which gives you cotangent of x minus cosecant of x quantity squared equals, where we're done with the problem. Okay, so that was kind of complicated. I thought so. But you just have to, you got to look for the trinomial. It's got to be a trinomial in there, a perfect square trinomial, to get to that point. Just for the heck of it, we're going to go the other way around, and I'm going to, just to see what would happen, okay, if I would actually simplify the other side. So let's try it. It might actually work out better, but let's give it a shot. Okay, so let me rewrite this again. 52 is going to be 1 minus cosine of x over 1 plus cosine of x equals cotangent of x minus cosecant of x quantity squared. So I'm going to work on the right side. The first thing I do is I'm going to write it twice just to help you FOIL it if you're not good at distributing that. And if I FOIL it, I get cotangent squared of x minus cotangent cosecant minus cotangent cosecant. So it's really minus 2 cotangent of x cosecant of x, and then plus cosecant squared of x. Okay, so that's FOILed out. And if I look at an identity, so we have a couple identities here, right? I have cotangent squared of x plus 1 equals cosecant squared of x. And I notice everything's in terms of cosine cosine on the left-hand side. So I am actually looking at this and going, this is actually pretty difficult. Just to do it the other way around, I mean, that's the whole point, is you try something, and if it doesn't work, I don't really see a great way to change all this stuff into, I mean, I guess I could do sines and cosines. Okay, we could try it. All right. Cotangent squared of x is cosine squared of x over sine squared of x minus 2 cosine of x over sine of x. And then cosecant is 1 over sine of x, so sine of x, okay? Plus 1 over sine squared of x. My common denominator is, oh, I have a common denominator here. So it's cosine squared of x minus 2 cosine of x plus 1 over sine squared of x. So they're all sine squared of x. Okay, that's kind of nice. Yeah, maybe it's going to work out okay. Well, we'll see. Do you notice that the top, I can factor to cosine of x minus 1 times cosine of x minus 1. Everybody okay with that one? And the bottom is sine squared of x, which is 1 minus cosine squared of x. Okay, I have to do one more step here. I can factor the bottom as the difference of two squares. So cosine of x minus 1 times cosine of x minus 1 over 1 minus cosine of x and 1 plus cosine of x. I'm missing something here. Okay, so I was just kind of staring at this one just for a second here. Basically what I'm doing is I'm going to factor out a negative. Here's the deal. I need a 1 plus cosine on the bottom, which I have, but I need a 1 minus cosine on top. And so the deal is I'm going to factor out a negative out of one of these. Right, that's this. Do you agree with that? Negative of 1 minus cosine gives me cosine of x minus 1. And then times cosine of x minus 1. And the bottom is 1 minus cosine of x and 1 plus cosine of x. So we're running a little bit out of room here, but I can cancel this one out with this one. And then I'm going to distribute the negative back to the problem. So if I have cosine of x minus 1, so if I distribute that, and it's easier if you see this. Here, let's do it over here. If I distribute that negative to the cosine of x minus 1, I get negative cosine of x plus 1, or 1 minus cosine of x over then 1 plus cosine of x. Woo! I would definitely, so that works. Okay, I would definitely not have done it that way. Ugh, I would have done it the first way that I did it. Because if you do it the second way, you will cry. I actually have tissues here right now and I'm crying. Okay. So let's move on. Whew, that was brutal. Okay, 55. Whew. It's kind of scary. Okay, sine squared, I'm going to do x. Sine squared of x, secant squared of x, plus sine squared of x, cosecant squared of x, equals secant squared of x. Okay, well, obviously the left-hand side. So sines and cosines. So sine squared of x, and then I'm going to move that secant to the bottom. That's going to give me cosine squared of x, plus sine squared of x. And I'm going to move this cosecant to the bottom, becomes sine squared of x. This is actually a pretty easy one. And sine over cosine is tangent, so tangent squared of x plus 1. And tangent squared of x plus 1 is secant squared of x. That was easy. Whew. Okay, put the Kleenex away from the last problem. All right, so that was pretty easy. That was 55. 56. cosecant of theta plus cotangent of theta over tangent of theta plus sine theta. And that equals cotangent of theta cosecant of theta. So it's kind of tempting to say, let's see, I've got, actually I have a little bit of everything. I have cosecants, cotangents, tangents, and sines. What I don't think I do is multiply by conjugate. And because the only reason I would say not to multiply by conjugate is because that tangent and sine, if I square them, they don't go together. Tangent goes with secant, but not with sine. So I would just go with sines and cosines right away. All right? So I get 1 over sine of theta plus cosine theta over sine theta divided by sine theta over cosine theta plus sine of theta. Okay. So I would get my common denominator, which is sine cosine. So I'm going to multiply this whole thing by sine theta cosine theta over sine theta cosine. We talked about that, about getting that common denominator, right? Kind of like if I have 1/3 plus 1/2 over 1/6 plus 1/3, something like that. I would multiply the top and the bottom by common denominator is 6 over 6. That would get rid of all fractions. So that's what I'm doing here. So if I multiply the first one, the sines cancel out and I get cosine of theta. If I multiply the second one, the sines cancel out and I get plus cosine squared of theta. On the bottom, I multiply the cosines cancel out and I get sine squared of theta. And on the bottom, I multiply, I get sine squared of theta times cosine of theta. All right, so that actually is a little cleaner now. I'm going to factor some stuff out of here. So top, I'm going to factor a cosine of theta out of here. So I get 1 plus cosine theta. And on the bottom, I'm going to factor out a sine squared of theta. And that gives me 1 plus cosine theta. Oh, that's actually really sweet. Because these cancel. And I get cosine over sine. So remember, cosine theta over sine theta. Right? Cosine over sine is, cotangent of theta. And then 1 over sine is cosecant of theta. And we're done. Okay, a little messy, but that's it. Okay? That wasn't bad. So common denominators, man. Common denominators. All right. 61. Let's see. Ooh, that one's scary looking. All right. Secant to the 4th of x. Ooh, they use s. We're using x. Minus tangent to the 4th of x over secant squared of x plus tangent squared of x equals secant squared of x minus tangent squared of x. All right, this is easier than you think, guys. This is just a factoring problem. That's all it is. Not even any identities here. That's a difference of 2 squares on top. So that's secant squared of x minus tangent squared of x times secant squared of x plus tangent squared of x. Okay, it's like saying x to the 4th minus y to the 4th. That would be x squared plus y squared, x squared minus y squared. And the bottom is secant squared of x plus tangent squared of x. Okay, so that cancels with that, and you wind up with just secant squared of x minus tangent squared of x, and then you're done with that problem. So that was just factoring. That's not even any knowledge of trig. Okay? All right, and last one, 65. It's going to be 1 plus cosine of x over 1 minus cosine of x minus 1 over cosine of x. Oh, sorry, 1 minus cosine of x. And at the bottom is 1 plus cosine of x. Okay, and that equals 4 cotangent of x cosecant of x. Ooh, 4 of them. That's a lot. Okay. Definitely common denominator. So I'm going to multiply this side by 1 plus cosine of x over 1 plus cosine of x. And this 1 minus cosine of x over 1 minus cosine of x. All right, so on top, you got to FOIL that out. It's kind of nasty and brutal. But if I FOIL that out, I get 1 plus 2 cosine of x plus cosine squared of x. On the bottom, I FOIL it out. So I'm going to leave that negative, though, because I need to distribute that later. So I'm going to get 1 minus 2 cosine of x plus cosine squared of x over 1 minus cosine squared of x. So if I distribute that negative, I get 1 plus 2 cosine of x plus cosine squared of x minus 1 plus 2 cosine of x minus cosine squared of x all over 1 minus cosine squared, which is going to be sine squared of x. Okay, so things cancel out here. The 1's definitely cancel, and the cosine squareds cancel. Okay, cool. So you have 2 cosine of x. I can just say, right, I'll simplify it more, sorry. 4 cosine, right? 4 cosine of x over sine squared of x. So remember, guys, this is in terms of cotangents and cosecants. So I'm going to split that sine of x up. So I get 4 cosine of x over sine x, sine x. And so here it is. 4 cosine over sine is 4 cotangent of x, and 1 over sine of x is cosecant of x. And we are done with the problem. Okay? So besides that one little crazy one where I tried to work on the other side, just to, you know, see what I could do, and people cried, this really wasn't that bad. So that's it, math fans. We have, let's say, quiz on this. Not next class, but the class after that, and it covers all kinds of different problems. So make sure, if I kind of had to summarize here a little bit of some of the things to look for, let me actually write down what to look for. You're always looking for common denominator. If you have 2 terms, and then you also have conjugate. And of course, our favorite is sines and cosines. Pythagorean identities. And those are kind of really the main ones that we're always looking for. I mean, there might be some factoring involved here too. So make sure you look for all that. So you're ready for the quiz. All right, that's it, my fans. Have an outstanding day. Adios. Goodbye.